Today we're looking at the composite rule. So the first thing we want to know is, what does a composite look like? Okay, so I've got two examples here. What you can see in that first function, you have an inside, which is just a polynomial, and then that's all being raised to a power of 7. Okay, so we can see the inside there, something raised to the power of 7. So the x to the power of 7 is your outside function, and then on the inside you have the polynomial. Similarly, if we look at the square root, the inside's a polynomial, the outside is a square root. Now what's going to happen is that we can deal with those two things separately. So on your formula sheet, the inside is called g of x, the outside is called f of x, but let's just call them inside and outside. I think you're going to find it easier. So the inside on this sine function is just the bit inside the brackets. Yeah? So we can deal with the outside first, just pretend that that's sin of x, and then later on we can deal with the inside. Okay? Looking at this one here, this last one, even though it's not so obvious, it's not in a bracket, we could deal with that exponent up there as being the inside of the function, because what's happening is we're taking an x, putting it into that function that's in the exponent, and then we're putting that in as the exponent for the e. So we can deal with those separately. It's going to make it much easier. So let's just have a look at what it actually says. Now on your formula sheet, it looks just like this. Now Mr. Alvin's not going to like that, so we're going to put it in some colours, and then we're going to try and interpret it. Okay, so we need some more colours. Right, so now we'll deal with the red part first, so don't even look at the blue part. We're going to forget it's even there. So what we've got is, we've got the outside, because that's what they're calling f, the outside, we're going to differentiate that. Wow, we're trying to differentiate, we start by differentiating. No surprises there. The g is a little bit surprising because there's no dash on it, which means we don't have to differentiate it. In fact, that is the same inside as the function had to start off with. So really, really simple. We just copy it straight from the question. Okay, and we're not quite finished yet. Right, we're not quite finished yet. We do still have to do something with the inside, and that is we then differentiate it and we multiply it on the end. So inside the brackets, it just stays as it was, and then we make another copy that we differentiate that goes on the outside. Does that make some sense? I hope so. Here's an example. So first step, forget about the inside. Okay, let's cover it. Yeah, and we'll differentiate the outside first. X to the power of 7. Well, I'm sure you all know how to do that. You're going to get 7x to the 6. Yep, good. Now, if you think you want a little bit more time to answer a question before I do, feel free. Okay, but that's what we're going to write. Now, what did I say about the inside? The inside stays just the same as it was. So we're just going to copy that across. Right? Yeah? Same. You can see that. Good, you've had some time. Now, the next bit. We need to differentiate the inside. Yeah? So we can put a little cover over so that we don't get distracted by the outside, and we're going to differentiate the outside there. Yeah? So you're all happy with that? And so hopefully, while I'm yakking away, you've done this, and you've got 2x minus 4. So we multiply that on. Okay, happy? Good, I knew you would be. Right, and take that away because it looks a bit ugly and silly, a bit childish, and boom, there we have it, the answer. Now we could possibly rearrange a few things there, but that's not what this today is about. We want to just move on, maybe do another question. What do you reckon? Okay? Right, oh, gee, that's not an easy one. How do I make it easier? Right, I can cover the inside, forget about it for a while. Okay, I can come back to that later. I'm not gonna let it bother me for now. Okay, so where am I? sine, I can work out how to differentiate that. I go to my formula sheet, I get cos. Well, 4 sine is just going to become 4 cos, isn't it? And the plus 12 on the end, well, what does plus 12 or plus anything do? It's just going to disappear. So we get 4 cos, whatever it is. Okay? Now, we can just copy the inside down straight from the question above. So we better remove those boxes. And then I'm finished. I can go and have it. Oh no, wait a minute. I've still got to differentiate the inside. So let's have a nice little trendy cover there, specially designed to block out the rest of the question. So we got 7 pi over 3 times x. Well, that's just some number times x. What happens when you differentiate that? You just get the number, and the x disappears. So we're just going to multiply that, 7 pi over 3, onto the end of our function, and then we really are finished. And, oh, I feel so good. We should do another question. What do you reckon? All good. Okay, let's have a look at this one. Right, so here, oh, it wouldn't be so hard if I didn't have that in the exponent. Oh, but wait a minute, I can cover it. Now, e to the x, there's a function I like to differentiate. Oh, I could differentiate that all day long. Of course, as you know, you will get, pause if you feel the need, but I know that you know, you're just going to get the same thing back. So dy by dx will be the same as dy. And of course the 2.8, yeah, that just comes down too. And so we get that. Boom. Copy down those exponents, just the same. No difference, except we still have to do that second part, right? Which is differentiate the number that's there in the exponent. So let's just put on our trendy little cover. Don't worry that it doesn't cover the 2 off to the side there. Focusing in on the inside of that box. So when we differentiate that, 6x plus 2. Yes? You all happy with where I got that from? You know. Right. Now, obviously, I could do some rearranging there. Not a terrible amount, but I could bring the bracket that's currently on the end, move it out the front, multiply it out or something, I don't know. Look, the main thing is that we're learning to differentiate today. If we can simplify, even better. That's great. But, you know what, this is going to get us most of the marks in the test, so let's just feel happy. Oh, let's take away that box, look at that question, go, I did that. Right, one more question. Oh, I promise this will be the last one, because it is a hard one. Let's have a look. What can we do? We want to cover the inside, and then it still doesn't look very nice. Now, rather than writing it as square root, let's write it as to the power of a half. Yeah? Okay, that's looking better. Now I can use my polynomial rule, which means I bring the exponent down the front and subtract away 1. So I'm going to have a half multiplied on the front, and when I take away 1, I'm going to have minus half as my exponent. We're all good with that? So, yep, there's my dy by dx. Right. Now, I'm going to be a little bit naughty here. I'm going to go on and I'm going to look at how that would rearrange, and then I'll come back and I'll finish in a minute. Wouldn't really recommend you do this in a test, because you might forget to go back. But what I'm going to do, how would that rearrange? Well, to the power of negative a half, that's negative is going to put it on the bottom line. The half's going to mean it's the square root, so I'm going to have 1 over, now the 2 from the half is going to have to go on the bottom, and then it'll be the square root of whatever your inside is, or your u, maybe you might be used to calling it, right? So you put that down. We could copy all the in, but of course I've been very naughty here, and I've forgotten to do something. So I'm going to have to go back a line, aren't I? What did I forget to do? Well, you know, you're all very bright young people. Wonderful, intelligent, bright young people. You know exactly what I forgot to do. You're shouting at the screen right now going, get on with it, Mr. Air. Right, I will then. Okay, so we cover over the outside, we just look at the inside, and we differentiate that. We multiply it on the end, and bada boom, bada bang, we get 24x to the power of 3, 9x to the power of 2. Right, so let's bring that in there. Now, when I wrote it on that bottom line, actually what I could have done was, instead of multiplying it on the side, I could just put it on the top, right? Because I'm going to be multiplying it by 1, so it'll replace the 1, and in it goes. Here we go. Whoa! That looks cool, doesn't it? Gosh, it's good having a computer. Right, well, thank you for listening. I hope that helped. I will produce some videos in the future to cover the other rules. This is the hard one, right? The rest, easy. Okay? This one's just a little bit hard, but it's not anymore, eh? Okay. So you have a good one. Don't study too hard. Don't stay up too late. All right.